if we have a light bulb attached to a coil of wire, so let's say this is a light bulb and this is a coil of wire. Normally, this light bulb is not going to light up because there's no voltage source. However, the bulb won't light up. However, unless if we bring a bar magnet into the situation, so let's just put a nice little bar magnet, and we move that bar magnet through this coil, now we have created an interaction between the magnetic force from this magnet and the electrons that reside in this wire. So unless we have a magnet to move through the coil, this magnet will exert a magnetic force on the electrons in the wire of the coil. Thereby creating an electric potential or a voltage. And that will get current flowing through this, and that light bulb will light up after all. Okay. There's a few things that will affect how much current we can get going through this. We can add more turns to the coil, so add more turns of wire to the coil, or make the area of each of these loops smaller to fit more tightly around the magnet. Make the area of each loop smaller, tighter around the magnet, so it experiences a greater magnitude of that magnetic force. To induce more current to flow. Or to get that thing lighting up brighter. Okay. On the other hand, if we were to move a wire, let's just switch pages here, through a stationary magnetic field, okay, so now let's assume we're moving a wire. Oops, let's assume we are moving a wire through a magnetic field, through a stationary magnetic field. How are we going to induce a current in that? How can we optimize, or how can we maximize, let's just say, maximize the amount of current induced? Well, let's draw a current carrying wire. So here's our current carrying wire, and let's draw that current carrying wire in a magnetic field that's coming out of the page, all around, let's just say. So here's our magnetic field represented by these dots And I want to know, how can we maximize the amount of current that's going to be induced in this current carrying wire? Well, we can maximize the amount by cutting these field lines perpendicularly. Okay, so the answer to this question is by cutting the magnetic field lines perpendicularly. That's how we're going to maximize the magnetic force on these electrons, by cutting the magnetic field lines perpendicularly. Well, this might be a little bit difficult to visualize, but these lines are all coming out of the page. That's what the dots mean. Okay, so how can I cut these perpendicularly? So here's my wire. These are all sticking up. If I move this wire up and down, it's not cutting through any of those field lines. Well, if these are all sticking out, I'm going to need to move this wire from left to right in order to cut through those field lines. So in this case, the wire should be moved from left to right, or right to left. Left to right / right to left, side to side, in order to cut those field lines. In order to cut those field lines perpendicular at a 90-degree angle. Okay, and that's, as I said before, that's going to maximize the amount of force on those electrons and really get them moving. Okay, let's do another diagram. Let's say here's my current carrying wire. So I just want to separate this so we don't mix it up. Okay, so here's my current carrying wire. Current carrying wire. So now my wire is sticking out of the page, if you can imagine that. And let's draw in some field lines. So let's go like this. Here's my magnetic field. Now my magnetic field is going side to side, right? Here's my magnetic field. Well, how am I going to maximize the amount of current through this current carrying wire? Well, I need to cut those lines perpendicularly. Well, right now this wire is sticking out of the page. If I move this wire side to side, I'm not going to get any current because I'm not getting the magnetic force to act on that wire. So in order to get current traveling through this wire, I'm going to need to move it up and down in order to induce the current. Because if I do that, I will be cutting through these lines perpendicularly. So in this case, in this scenario, I can induce a current in the wire by moving the wire up and down. That is going to get that perpendicular interaction that's going to maximize the amount of magnetic force that's acting on my wire.